Of PythonJamaica for 2016. My talk was nominally called that, but in reality it's more like that, right? So it's Postgres tips for a Python coder. My name is Rhys Stewart. I work at the local power company. Yeah, the local power company. Yeah, Oh, sorry. What happened?
It fell asleep.
Oh, you don't plug it in? Don't plug it in?
No, it fell asleep. The machine fell asleep.
So will it fall asleep again? Okay. Right. I'm not representing them.
That's good.
Right, right. All right, so I don't do much coding. I don't call myself a coder, but from time to time I may do a small website here or there, but nothing professional. I like using Python because it's very easy and simple to use, and it doesn't have many curly braces, which yeah, I know. It's, whew. All right, so the gist of the talk will be when you decide to come up. All right, cool. So we'll speak a little bit about what is Postgresql. Do you all know what Postgresql is, by the way? Yeah, okay. I'll tell you shortly. Python outside of Postgresql, Python inside Postgresql, and then just some tips that you should know, like Postgres tips, basically. All right, so what is Postgresql? Postgresql builds itself as the world's most advanced open source database, right? Ooh. Which I believe is a very true statement. Anytime today, Mr. Slides. All right, cool. So what does that mean? It's a database, like it stores data, clearly, but it's more advanced. It has many data types, operators, indexes, and when I mean data types, not just integer or text or time, but like one they might not think of, like CIDR for internet addresses or IP addresses, stuff like that. Booleans, that's the regular one. But there are a bunch of different types, and with these types, you have operators to work on the types, because having a type by itself is kind of useless, right? So there are lots of different things you can do.
Fell asleep. Do you want to just use the...
No, I like standing here.
You can move around.
All right. Back up? All right, cool. So I'll just stay here then, I guess. Right, so a lot of different types, a lot of operators for those types, and indexes on those types, because a database without a proper indexing system is kind of useless. Like if you have a million rows, to go and search through every single row would really make sense, right? So with that said, how do you access PostgreSQL from outside? With Python, for example. The most common library is CyclePG2. There are other libraries, but this one is, I feel, the most full-fledged, most functional. It has support for almost everything Postgres has to offer. So let's get into a little code. Can you all see that? It's not too small, is it? All right, so it's a Python module. You import it, and you connect with CyclePG Connect. You pass it a string, which is the URI for the database, and then the next thing you'll do is create a cursor, and the cursor is what you use to query the database, right? Now, the beauty about CyclePG2 is that it basically adapts or translates the PostgreSQL types to Python types pretty seamlessly. So this query right here basically says, right, select 1 plus 3, which is 4. You get back an integer, which is, you're seeing right here. You get decimal types, for example, with where am I? Floats, rather with numerics. Floats come out as regular floats, And then arbitrary text is just a regular text, and then an array or a Postgresql array comes out at the Python list. So it translates it pretty seamlessly, which is always good. Here's another one, which basically, this query generates a series from 1 to 4 with some random numbers on the right-hand side. To access the data, which I should have said first, my humble apologies, you use the fetch1 method or fetch_all method in the cursor. All right, cool. So you can also use scroll to go back up or down, and row number to know which row number you're actually at. Did it move yet? All right. Now, you may have noticed a while ago that you got back. Go back a little bit, please. Right, you get back a list of tuples. So one list or rather one tuple per row. To access each individual tuple, you have to do the indexing, right? Which can kind of get a little annoying. So there are other types of cursors you can use. There's a dictionary cursor, named tuple cursor, a bunch of them. So you access these by going to import you import extras from CyclePG2. So here, when you do the connection, we pass in a cursor factory, which gives you, this is the real dictionary cursor or real dict cursor. And here now you'll get a dictionary instead of a tuple for each row you get back, right? Again, we're using the fetch_all method to basically bring back everything in one fell swoop. If it is that you have like a wad of data, I mean like a lot of data, you don't want to do this because fetch_all will fetch everything at one time. And if you do a cursor query on the entire table of, I don't know, like a million rows, and you have a very regular laptop, it will bring back it will try to bring back the million rows one time. And if you're memory constrained, then that could be an issue. Oh. All right. Right. So I'm going to show you how to push out stuff from CyclePG2 to in a JSON format. And I should have mentioned, I'm sorry again, that PostgreSQL supports JSON internally. If you push out JSON from PostgreSQL, it will come in as a Python dictionary, which basically makes sense. So, ooh, no sleep. All right, so the query, I can't even highlight. The query here, are you seeing the highlight? Yep. All right, cool. So let's start up here. So we import the JSON module. And then we're going to basically pass in, this is the same query from up here, the same cursor from up here rather. We're going to pass in the data and it spits out regular JSON. Note, however, that if you were to spit out JSON from PostgreSQL, which is right here, you get back a dictionary, which if you're like me and you have a lot of, I like to use bottle a lot, and I usually keep it very, very simple. So I like pass stuff from PostgreSQL into bottle, or you all use bottle or flask? Close enough. Yeah, but bottle is better. We all know that. Anyway, moving on. Right. I usually push the data right up to the user. I rarely use any like Django type stuff because I'm not really a coder, as I mentioned before. So bottle/flask is very simple for me to use, right? So I included y'all. All right. So where is I? All right. So you get back out your dictionary. What I actually do is I actually get text out of the database directly, so it comes out as a string, and then I don't have to do any more casting at this level here to push up to my client, or the client rather. Alrighty. What else is there? Oh, this is part of the tips side. In terms of transactions and committing. Now, I'm going to put up here at the front. This is, we do the import. we create a dictionary, right? Now we're going to split the screen into two different, imagine that there are two different computers. So on the left, not up yet. All right. On the left, we're going to turn Autocommit on, right? Now, Autocommit basically says, all right, for every query you run, commit right away. Don't wait on a commit statement. And this is tremendously important if you have a very large system and you have lots of activity. You get a thing we call idle in transaction, which Postgres people don't like because that basically uses up resources while nothing is going on. All right, so turn autocommit to true. That will solve that problem. So every query you run, it will commit at the same time. Now, I ran up here, you're seeing here? Yeah. So this is the same table, same query on both sides, right? So notice it brings back, 4 records. And I'm going to update the table on both sides. So on the left-hand side, I set elf equal to turvy, where nomad is equal to 6. On the right side, I set elf equal to topsy, where it's equal to 8, right? If I now run a select again to just show me what 6 and 8 now are, on the left-hand side, you'll see, on the right-hand side rather, you'll see that it's going to come back sometime soon. All right, good. It's going to come back with turvy and topsy because it's been committed on the left-hand side. On the right-hand side, it's still showing turvy and STPR, whatever STPR is, because I haven't committed on the right-hand side yet. Once I commit on the right-hand side and run the query again, then all is well with the world. Both clients are seeing the same thing. So the autocommit is important, especially for that reason I mentioned, where you have idling transaction. All right, now this is Python inside Postgresql. Postgresql is a very extensible database, and I mean extensible to like the core. You have, well, this is a procedural language. You have several procedural languages. You have PL Python, JavaScript, PL V8, PL Perl. Right, the built-in one, PL SQL, there's PL lolcode, and a whole bunch more. All right, so PL Python, you have to install it. It ships with PostgreSQL, but you have to install it by doing create extension. Depending on if you have Python 2 or Python 3 on the box, you can either install, it will come shortly, PL Python 2 or PL Python 3. Wow. I'm having network problems, my humble apologies. I shall keep going. Right, you have PL Python 2 or PL Python 3, depending on which Python you have installed, right? Once the slide comes up, you'll see that there's a U appended to the end of it. The U means untrusted. Now, because Python can be used to modify the file system and do many other things, we can't allow any old user to write a query or create functions from PL Python that could theoretically compromise the system. So only the super user can create a function. Only the super user can install the actual extension. All right, I think I'm back. All right, cool, right. So you have PL Python 2U and 3U. Some more code coming up. All right, so as super user, you'd run this, create extension PL Python U, and I'll create the extension. This block of code here is called an ACB, or a anonymous code block, which is a thing in PostgreSQL. So you start with do, and then these two $signs are how we quote in PostgreSQL, especially if it's a long string of text that has many quotes in there, right? Or many other like actual quotes, single or double. So this is straight Python right here. You import requests, give it a URL. I get the URL. I create a table here, and then I go through the actual. I split the URL, split the text from the URL, and I insert it into a table, right? And you get back this. So if you now do select all from contrived, which is the table name, you get the actual text of what was in there. That's a very contrived example. I mean, nobody really does this in real life. Well, I mean, I did a while ago, but nobody else would do it in real life. Now, an actual function that you'd write, and this one I use in my day-to-day work. When I started working at the local power company, it must not be named. When I started working there, I got a lot of data in Excel spreadsheets and had to like import it into a database. So I'd usually look at it, Excel spreadsheet, then create a table manually, and then do copy into the table, right? Took some time, and I'm a very lazy person. So this function alleviates all of that problem. It's called paste to table. You give it a table name, a word of text, and it will do everything for you. Take the first line, create a table and the rows. And then it will populate the rest of the table with the rest of the rows. I had done this in PythonJamaica first, which is the built-in procedural language that Postgres ships with. And all was well with the world until one day I got a table with around 15,000 rows. And I did paste the table, hit paste, hit enter, and it's probably still running right now. Because PythonJamaica is notoriously slow for doing anything other than database access, right? So I said, well, let me have Python, let me do it this way. I did it this way, and I can now routinely drop in Excel sheets with 100,000 rows in there, and in 3 or 4 seconds it's finished, right? And again, this is there's nothing fancy out it to the regular Python, nothing extra, except for a couple of things which I shall point out now. You may notice you have here a PLPy library, which I did not import. It's imported automatically once you start a function, right? The PLPy library provides database access functions. So you can execute a query, which is right here. Notice is to give you a notice, which is like a warning or an error. And there are a couple more. You may notice one more down. Where did it go?
Notice is like print?
Yeah.
Or is it something that ends up in the database?
No, it's a print, like a print statement. And there are, here it is, PLPy quote literal. So this will help with your quoting. If you're going to enter actual data into the database, it will help with quoting. So if it's already quoted, it will properly, what's that word?
Escape the code.
There you go, escape the codes for you. All right. Oh, sorry. Alrighty, wrong way. All right, so here's an example of how it looks. All right, so it's very, very straightforward. Select paste the table, give the table name, and then you drop the body of text again between the two dollar quotes. Hit run, and this is the notice you're getting back actually, right here. That's the notice you're talking about, right? All right, and then now you have data in the table. All right. Right. All right, cool. So that's PL-Python. It's just Python in database. It's very useful, for, as I mentioned, doing text-based stuff that maybe PL-PGSQL is not so hot with. You could get very crazy and creative and start calling requests every now and then. I wouldn't recommend that in a production system because if you call out to an URL, for example, and it's just hung up there, you'll just wait and wait until who knows when. You could. I'm not sure how you'll come back wait for the call though.
So the Postgres web server for that actual thing, right?
All right, moving on. We will. Yeah, you could run Flask in it, but I mean.
What do you mean? What does that mean?
it's a bit much. All right, cool. All right, so the tips you were promised. All right, these tips I have, not being a coder, I do things my way, right? And I've noticed that some coders do things which are not my way, which just happen to be the wrong way. In this case, with Postgresql. One of the things that the people are always doing is installing Postgresql. You know all of this comic, right? Yeah. Yeah, this SQL injection comic. SQL injection cannot happen if you have proper privileges in place, right? So you can inject all you want. If you can't actually write to the table or drop the table, then you can't do a thing, right? You go to pretending command, you get errors back basically. So, still not up yet. Right, have separate rules for creating tables and querying tables. A lot of people will install PostgreSQL and see that, all right, type psql Postgres to start, type it in and run with it, right? And then like years later, realize they only have one user and that user has access to everything in the world. It's not up yet. Oh. All right, so generally I think, or I try to tell people to, for every application you're using, create a user for that app, and then create a second user that has like read-only access to the data in that app, right? It's taking a while. Oh, sorry. Right, so you do create role, app owner, and he can log in, create stuff, create more roles, create the database, and then you have a user just to read alone. And if you want to get really, really, paranoid, you can have a user to like write also as well, and then one to like. In fact, if you can create that, if you can create the app owner, do this stuff, create other users, and then delete app owner, that's great, because then no one can really delete anything else. It's all there. All right. How many people here like SQL? How many people here love SQL? One person. Anyway, who here knows what a common table expression is? Or CTE? No? Oh, okay. All right, so I've heard that it's worse to, the only thing worse than writing SQL is reading somebody else's SQL. So common table expressions make your life easier in the sense that it makes SQL very readable. So it looks almost like regular code, for example. So they're known as with queries. So they look like this. With something, select regular stuff from, and in this case, I'm joining it back to list. Let me highlight here. So this is, oopsie. Ooh. Let me go this way then. All right, so all of this is one query, and it's basically like a materialized view in a query, right? And it's very useful for visibility. So especially in the case where you would have had several subselects before, you can now migrate them up to the top. You have with this, something here, then comma, that, something there, then do something with this and that, right? And if you are really enticed, you can actually add recursive to it, and it can actually recurse on data you've had before. So you can now actually like do for loops right in the SQL right there, and do wonderful stuff. As with all things that are very nice, there are some caveats with PostgreSQL. So the query planner doesn't really go into the with block. So whatever you do in the with list is just set in stone, and you can't optimize beyond it. So I'm going to show you an example. This query at the top returns the same as this bottom query, right? So if you can see, literally all I did was move the list up here into a subselect under the left join. So all of that is in the list at top. Fair? The query at the top took 4 minutes and 10 seconds to run. The query at the bottom took a second and a half. Because, again, bottom query, the planner can actually look into it and use indexes, whereas the top query, as far as it's concerned, is just doing a regular union, so there's no need for indexes, right? The bottom query can say that there are indexes on the actual columns and say, all right, wait, I know what to do, and I can make it much faster. To use them, what I usually do is if you have a lot of, like if it's a long running query anyway, like with like millions of rows, then you already make a difference, you do width. If it's a production query, I like spec it out like this at the top, and then transform it afterwards to take advantage of any indexes that are there. Listen, notify. Earlier Mark mentioned celery, right? Which is, remind me again, please? Celery. Messaging, right, a messaging application. You all know RabbitMQ, right? Another kind of message passing software. All right. Eh? Oh, okay. All right, cool. All right, cool. So listen notify. Listen notify is like is effectively like RabbitMQ, just a bit smaller. So you can now send messages between, well, anything connected to your database. So it's very, very handy. I haven't used it much because I work at a power company. But it's very simple to use. Ready to go. 1 second. All right, cool. Yeah, you start by saying, listen, give it a name. This is a channel name, or it would be called a channel. So link up. And you can say, for example, notify link up about chop, right? So you say notify link up, comma, chop, and then a message will be sent to anybody connected that is listing on link up that, hey, a notification was sent with the payload chop received from wherever, whatever. Ooh. All right, cool. In Python now, this is at the bottom here, this is Python. There is a package called pg_pub_sub, which makes it very easy. If you're using CyclePG2 by itself to implement this, it's lines of code. But since you're going to be doing it over and over and over, you can condense it, which this guy has done, and call it pg_pub_sub. So it's very, very, very simple. You give it the URI, you connect, you listen on a channel, and then whenever someone notifies that channel, you get a response. I haven't had chances to use this, but you could, in theory, replace what Mark has done with Celery with this. Does it scale up to like a gazillion people? Probably not. I don't know. I haven't tried it that much yet. But I find that for most things under, I don't know, 20 million, 50 million rows, Postgresql worked very, very, very well, even on small systems. All right. 20 or 50 or 60.
20 or 50 or 60 million?
Yeah. All right. So it's, all right, it's about time. All right, cool. There are two types of time. There are two types of types that deal with time. There we go. Yeah. All right. So here's a query. It says, all right. So the extreme right column has a time, right? So you're seeing this is with a -5 at the end. You always want to use timestamp with time zone. All right? I've seen people just use timestamp alone because typing timestamp is shorter than typing timestamp TZ, which I did initially until I found out. Ooh. Sorry. Right. Now, how Postgres works is it stores all the timestamps, all time, well, as UTC, right? So if I'm in Saigon, for example, and I set my time zone to Saigon, and I store time, it'll convert it to UTC right away. If I access the same database from here in Kingston, and my client says I'm in Kingston, it will give me the time corrected for Kingston. So never use timestamp alone because it will always get you muddled up if you have, especially if you have people around the world querying a database. Now, big data. Where do you think big data begins? Like, what number of rows would you call big data? Anybody? Go again? All right. So, there are, as I mentioned earlier, the 60 million rows is quite easy to work with. 100 million rows in one instance, in one table, is not so bad. Going above that, going above that might get a bit, dicey in terms of working, like doing actual stuff in a regular, efficient way. Now, there's this thing called a Brin index, right? Which means a block range index. If you have, if your data is generally ordered, and it's like millions and millions, like, I don't mean like 50, 60, I mean like probably 120, 200, like who knows where it's going to end. Then you want to use a block range index on your data. Come on. All right, so I have a table here called nuff, right? And it has 470 million rows. So it has 400 million, right, 400 million rows. If I were to query for one thing, you'll be very, very, well, let me have it catch up first. All right, I'm going to create an index on nuff. Now, I want to point out two things to you with PostgreSQL. Counting in PostgreSQL is very expensive, right? Because of how it works, there are no like shortcuts to count. You can't index counting or not. It's just going to take a long time. It will go through every row to make sure it gives the right answer. So it took 27 seconds for the count. To create a regular index took 35 seconds. The index size, which I'm going to show you shortly, is not terribly small. Oh, I'm sorry. There's a right. So I created a second index, the Brin index. This one took 7 seconds to create. Woo. All right. So let me now show you the size of the indices. So you can see where nuff Brin is 64 kilobytes, and the regular B-tree index is about a gigabyte. The table size is a gigabyte, well, almost 2 gigabytes. So the index size is half as big as the regular table. Because Postgres likes to put things in memory, if you're short on memory and your index can't fit in there, it's not a good thing. So you'll find that using the Brin index, which is very, very small, will be useful. It will still be slower in querying than a regular B-tree index, but not by much, because you still have to go. It basically stores the top end and bottom end of each page and what is the maximum figure of a column in there. So if you're doing like count from like 1 to a quadrillion, you'll be like, all right, this page has 1 down to 45, this one 46 down to whatever. So you'll say, all right, give me the one for 45. You check the Brin index quickly. All right, go to page 14, or whatever it's called pages on the disk. Go to that page, and it will then do a secondary scan on the page for the data. So it's still slower than the B-tree, but not by much. So the B-tree index will probably get through this in like, I don't know, 10 milliseconds or something. The Brin, probably about half a second. 1 second. All right. More about indexes.
10 milliseconds versus 30 seconds?
Noted, about half a second.
Oh.
Nobody uses that. All right, where are we at? All right, so Gin is the chaser, if you hadn't known, right? So there is a thing called a generalized inverted index, which we use for basically all the unstructured data in PostgreSQL. Arrays, JSON types, I should have put JSON-B, or text search, TS vectors, which are text search data types. Just use Gin, your life will be better for it, right? Oopsie, all right. Is it moving? Oh, wow. All right, so PostgreSQL's one of PostgreSQL's most recent features was JSON. There are two JSON types. JSON, which is like a regular text type, which basically when you put JSON in, it just checks that it's actual JSON, right? Nothing special about it. The fancier type is JSON-B, which means, I think, binary JSON or beta JSON. And if you cooperate with me, it is fully indexable, which is great. Indexes are fantastic, right? So I have a table here with one record called JSON test. There are a couple of operators which are useful. So what I've seen people do is like pull JSON out into Flask or whatever, work on it there, and then send off data, right? Now you can do all this right in database, one time, boom. Alrighty. While I'm pausing, any questions? Du- 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 du. Bummer. Alrighty. Did the net go down? Let me try something there. All right, I have to log in. Give me a second.
Pretty fast question. When you were working in PL Python,
Mhm.
did you find any gotchas in terms of like things that you think would be more efficient because you're
In Python?
taking that you would think would be more efficient in Python, you're moving the operation from the actual query path, but then realized after you ran it, it was way more inefficient. It was better to just write the SQL instead.
No, I haven't actually. One thing I did find that was funny, which is not related to actual Python, is that it's sometimes you'd think that, which is totally unrelated by the way. We mentioned efficiencies. The case statement, right? So if you don't, you case this then that or that then that, whatever. I was working with someone once, and the person had used a bunch of, had actually run like 10 different queries for each case. So that's dumb. Just do a case statement. It was much faster. But it actually wasn't at the time. That was very, very strange. But no, with respect to Python, I haven't found that. Let me log in. Oh, but it's not my laptop, huh? All right. I shall continue without slides.
Can you just control from the computer instead of your phone?
Come again? Well, I'll have to log in first, that's why.
Oh.
Yeah.
Even with the other, this next slide, you can't just keep on that. Or space.
Arrow keys, well wishes, voodoo, no, nothing going on here.
You can try running this in incognito mode.
Over the incognito, we're gonna log in.
Oh, hold on. No, it's stuck right here. I'm not sure why.
Run this in incognito mode.
All right, try that.
And you can sign in. Should be.
That way I can't say
Right, so where are they? JSON. Right, so we can do the queries directly in the database with some operators. Dash right arrow or dash greater than is your friend. You can actually chain it together as seen here. So in this case, we're pulling the menu item directly from the payload, right there. Oh, much better now. Or you can use the hash right arrow, which will pull it out one time. As in, you give it a path, and you pull it out one time, right? The hash right arrow is more efficient because it does one operation, whereas if you do the chaining, it's pulling out menu, then pop-up, then menu item. But beyond that, what I really like is that you can actually push out JSON very, very simply. This is the right slide? Yeah, so there's a row to JSON function, route to JSON function, which will take your regular table, JSONify it, and spit it back to you. And then you can go one further and actually get the aggregate directly in the database. So you can do JSON ag, and then you do route, and then you do route to JSON. You get one string through the world. Very, very simple and straightforward. So I've moved all my JSON stuff into the database. I've actually moved everything into the database. I really, literally, all I do is just do the query and push to the client if I'm using Bottle. All right, full text search. Who knows what full text search is? Lorena alluded to it earlier with tokenizing and stemming. All right, cool. So PostgreSQL has full text search built right in. No need to go anywhere else, like to Lucerne or Lucene or Lucene, yeah. I've seen this before, where you have your this talking to your that, talking to something else, talking to something else, talking to one more thing to get to your data, to get to your client. I like to keep it very, very simple. This is my approach, right? So you can put everything in a one box, query it one time. Again, because this supports the indexing, the full text search is very, very fast. And you can use custom dictionaries. Lorena mentioned that you're using English, and there are many more dictionaries. There are many more dictionaries as well in PostgreSQL. In fact, the dictionary, which I used recently at the workplace I work at, called the Addressing Dictionary. No, addressing is not a language, but I work in GIS and spatial stuff, right? So addressing for me is important. So when I had people doing queries and I would type in, for example, 45 Belmont RD, it wouldn't pop up because there's no RD in there. But there's a dictionary called the Addressing Dictionary that will say, all right, RD really means road, AVE really means avenue. Just like how you could stem, longer things, like in English to, shopping to shops and whatnot. It does the same for like that kind of thing. And because I keep everything in one place, especially for my work, like with spatial stuff, if I get a query in, I want to know that the system executes it in the most efficient way. So if, for example, I'm saying, all right, show me all coffee shops, that have reviews with the word top, right? I want to know that it will say, all right, cool, this is your data you have. It's better I go and hit the full text index first and then go to the spatial index, or vice versa. Whereas if you have this stuff over here, it might not be very possible, because you're just going to hit like one first arbitrarily, or you have to communicate. You basically have to build your own query planner above all of this to have the kind of efficiency that I like. All right, that's full text search. And now the creme de la creme of PostgreSQL are extensions. Extensions are the new fad, the new thing. I did mention a lot of things come in core Postgres. There are a lot of things that are outside of core Postgres that are fantastic. The most popular one is probably PostGIS, which is what I use to do spatial stuff at work. Everybody uses PostGIS, as far as I can tell, from Ordnance Survey in England, France's land cadastral people, everybody except for Jamaica. I mean, we use proprietary stuff still, but we're changing hopefully soon. If you have any questions that relate to the universal foreign key, which I like to, do you all know what that is, by the way? The universal foreign key? No? It's location. Right, so if you know where I'm located, I can have disparate data sets, for example. Like I can get data sets from Statin, which is Jamaica's statistics bureau, about different areas. So if I know that this area has, for example, low crime or low poverty, for example, I have a different data set which is wholly unrelated. But if I know the location, then it's a foreign key right there. I can merge or can join two data sets like that. What else is there? There is all right. So I mentioned this earlier about scale. No, I did mention it. If you can throw memory and cores at PostgreSQL, it will purr happily, right? Give it 200 gigabytes of RAM, you'll be fine with your 200 gigabytes of data in the RAM. If you do need to scale horizontally, though, then you might need some help. There are a couple extensions for that, namely PG Shard, CStore, and then there is Citus, which was recently open sourced about last year, I think. And Citus basically gives you distributed Postgres for effectively free. It's very, very simple. They're like 4 functions they run, and once you have the actual hardware sitting down, then you're good to go. There are also foreign data wrappers. You can query disparate sources from within PostgreSQL. You can query another PostgreSQL database, Redis, MongoDB, CStore, files. OGR is what I use again because it's of a spatial nature. A couple of these are writable as well. And in the Postgres FTW case, it will push down the queries to the foreign server so it's more efficient. Like MongoDB, it will actually bring the data back to you and run the query there. And you can do your own FTW if you want. There's a wrapper called Multicorn, and it's written in Python. So you can basically write, if you write any kind of FTW you want based on your needs. And this line down here is a GitHub link to FTW that can control Philips Hue lights. Y'all know the Philips Hue lights? Yeah. So someone wrote an FTW to basically, at his SQL terminal, like turn lights on, change colors and whatnot. So you can go from like real enterprise stuff to arbitrary run-of-the-mill things that will float your boat. There is pgxm.org, which is where all the extensions are stored. And now it's time for questions. Not built in. There are 2 popular ones, PG Bounce and PG Pool. And to a lesser extent, I think, yeah, those are the 2 popular ones. And they do it at different levels. No. I haven't used that. I do, but I don't have a large number of users. That's the difference. So, I mean, I have a lot of data to work with, but I'm the only one querying it really, like me and one other person. If you do have like, a bag of people querying, then that'll be useful. Right. Mm-hmm. All right, no more questions? Hooray! All right, thank you.